Today we're going to learn about trig graphs with an amplitude change. And before we get on that, it's important to know what an amplitude is. So if I give you some function y equals a sine of x, well, this a is the amplitude, and the amplitude, I'm going to type this out, amplitude is how far high or not or and low the function will go. So let's go and move that there. So let's take a look at some real examples of this, because amplitude is actually really easy. It's the first change that we're going to deal with when it comes to trig functions, because it's not all going to be sine of x, cosine of x, and tangent of x. They're going to introduce to you some different things. But let's take a look at sine of x first. If I look at just regular sine of x, what that is hopefully by now you know that it waves like that. It ends at 2 pi. Halfway between is pi. Pi over 2 is a quarter of the way, and then 3 pi over 2 is 3/4 of the way. 0, all right? And let's not forget our arrows. Now, we have established a couple times already that the peak height is 1 and that the lowest valley is -1. All right? Sine goes up to 1 and goes down to -1, and that's because the unit circle has a radius of 1 and blah, blah, blah. Well, what we can extrapolate from this is that the amplitude of this function is 1 because it only reaches the highest point at 1 and the lowest point at -1. So if I decide to modify the amplitude of sine by, say, putting y equals 4 sine of x, what that does is it stretches my sine graph by a factor of 4. So instead of having a peak at 1 and a trough of -1, my highest point will be 4, and my lowest point will be -4. The behavior of sine is going to stay the same. It just reaches something higher. Right? And it looks kind of the same because I just scaled it a little bit differently. So from 0 to 2 pi, it's going to stay the same. Halfway is pi, pi over 2, and 3 pi over 2. And I could do another one if I said y equals, say, 17 sine of x. All that would require me to do is to change the highest point to 17 and the lowest point to -17. And it will still do that. Right? And so that's going to be 2 pi, pi, pi over 2, and 3 pi over 2. All right, so I could throw any number in here I want. So let's go ahead and take a look at an amplitude change for cosine. We'll do maybe 2 examples of that. And an amplitude change for tangent. And then an amplitude change for the other 3. Okay, so let's do a couple for cosine. If I say y equals 5 cosine of x, well, cosine's regular graphical function looks like this, where originally the highest and lowest points are at 1. So if I make the amplitude 5, the highest point will be 5 and the lowest point will be -5, and everything else will stay the same. I think that amplitude changes are pretty simple. Right? So if I do another one, if I say make this y equals 25 cosine of x, it's the same thing, except now my scale is by 25. 2 pi, pi, pi over 2, and 3 pi over 2. Okay, now a couple things you guys got to know about sine and cosine. Sine and cosine versus tangent, both sine and cosine have an amplitude of 1. They have a default amplitude of 1. They go up to 1 and they go down to -1. The other trig functions like tangent, cosecant, and everything, they don't have an amplitude, and that's because there's no upper limit and lower limit for these functions. So if I take a look at y equals tangent of x, right, if we go pi over 2, pi, 3 pi over 2, and 2 pi, oops, well, we have asymptotes at pi over 2 and 3 pi over 2. And so notice how tangent keeps going upward and it extends without bound. Down here extends without bound, up here extends without bound, and down extends without bound. Tangent has no amplitude. So how is it that the numbers out front affect tangent? So if I say y equals 2 tangent of x, well, all that does, if you think about, let's take a look at an example that we do know. Y equals x squared versus y equals 2x squared. Well, x squared had this behavior to it. 2x squared, all that did is it just made it a little bit skinnier. And if I said y equals 21x squared, that would be even skinnier than the last one. So the way these are demonstrated, these are modeled, is the bigger the number, the more steep the graph becomes. So at pi over 2, pi, 3 pi over 2, and 2 pi, my asymptotes haven't changed. But now, instead of the graph growing like a regular tangent, it grows a little bit skinnier than before. And it's hard to show a lot of accuracy with that. So don't freak out. All right? So that's pretty much your amplitude changed graphs. Let's take a look at the other ones, like cosecant and all of them. Okay, if I look at something like y equals cosecant of x, well, if you're not used to it by now, sometimes it's easier just to go ahead and draw a sign, right? And then know that where the graph crosses the x-axis, that's going to be where your asymptotes are. And then your cosecant graph will look like this. Right, where our maximum was 1 and our minimum was -1. Well, when it comes to cosecant, cosecant doesn't have an amplitude because it extends up and down forever. So if I do something like y equals 3 cosecant of x, well, that just means that it's the original sine graph goes up to 3 and -3, and it's going to be a little bit skinnier, right? 2 pi, and then pi over 2, 3 pi over 2. So if I'm looking at cosecant, I'm going to change colors because I don't think the other one turned out okay. I'm going to have my asymptotes here. Those are the best asymptotes that I can do. And then because of this 3, it's going to grow skinnier. All right. Let's take a look at secant and then cotangent. Okay, I'm going to jump straight into a couple of examples with secant because I think you guys are getting the hang of this. Y equals, say, 5 secant of x. So let's go ahead and just draw cosine. Looks like that from 0 to 2 pi. Oops, those 2's are not very nice looking. Remember, at the points where the graph crosses the x-axis, that's going to be where your asymptotes are. And then for secant, it's just going to grow skinnier. And again, I'm not really too picky on the skinniness of it. And let's not forget our labeling. 0, and this is 5, and this is -5. And then last but not least, cotangent. Oops, change colors. Cotangent, if you hopefully remember, has asymptotes at pi, at 2 pi, and at 0. That's where your asymptotes are going to be. And it intersects at pi over 2 and 3 pi over 2. So if I say made this suddenly 7 cotangent of x, it just grows really, really, really skinny. Okay, so let's take a look at one last type of amplitude change, and that is a negative amplitude, or a negative coefficient out in front, and it's pretty easy. If I say y equals negative sine of x, well, if you remember back from the past, if I said y equals negative x squared, all this does is it flips the graph upside down. Negative sine of x, all that does is from 0 to 2 pi, it flips the graph upside down. So if you remember correctly from sine used to arc up and then come down and come back. So now, instead of arcing up first, it's going to arc down first, and it's going to look upside down. And this becomes 2 pi, pi over 2. Excuse me, I just sneezed. Bless me. And our upper limit is negative 1, 1 and negative 1. All right, so let's see if we do something a little more complicated with cosine. Oops. Okay, with cosine, if I say y equals negative 4 cosine of x, well, we know that our upper bound is going to be 4 and our lower bound is going to be negative 4, and it starts at 0. Well, cosine usually starts at high and then goes low and comes back up, but because we're upside down, we're going to start low, we're going to jump up high, and we're going to come back down. It's going to look like a bell curve. And it ends at 2 pi, and pi here, 3 pi over 2, and pi over 2. All right, let's take a look at tangent with a negative, and after that I will trust that you can do the reciprocal functions on your own. So y equals a negative 3 tangent of x. So what that looks like is it looks like this. Remember, with tangent, we've got asymptotes at pi over 2 and 3 pi over 2. And we've got pi in the middle and 2 pi. So tangent is upside down. So it used to arc up, and now it's going to arc down and be a little skinnier because of the 3. So tangent, when it's reciprocated like this, when it's flipped upside down, looks a lot like cotangent. And you don't need this other piece there because this is going to venture into 5 pi over 2. Okay, that's it for amplitude change in the trig graphs. We'll see you next time.